This is example 2 on topic shaft subjected to combined bending and torsion. Example 2 is a shaft of 100 diameter transmits 200 kilowatt power at 200 rpm revolution per minute. At a section, bending moment is 5 kN meter. Find the principal stresses, maximum shear stresses and principal plane. So given data is diameter of that shaft is 100 mm, power is 200 kilowatt, that means 200 into 10 raised to 3 watt. Bending moment is 5 kilonewton meter. This moment is always in unit kilonewton meter or Newton mm. With Newton, mm comes and with kilonewton, meter comes. So remember this. And this number of revolutions are denoted as n 200 rpm. And to find principal stresses, that means maximum principal stress, minimum principal stress, and the maximum shear stress, that means tau max, and principal plane, that means angle theta. So first see principal stress is 1 by Zp multiply by m plus minus under root of bending moment square plus twisting square. So here we don't know this T and this Zp. So for solid shaft, this Zp is pi d cube by 16. Pi, we know d is 100 mm. So it is 196.34 into 10 raised to 3 mm cube. 196.34 into 10 raised to 3 mm cube. And for calculation of this T, we know power formula. Power formula is 2 pi L T upon 60. This 2 as it is, pi as it is, number of revolutions are 200. T is our problem statement and 60. So this P is 200 into 10 raised to 3 watt. So this unit is in watt and this T comes, see, watt rpm, T comes in 200 into 10 raised to 3 multiply by 60 divided by 2 into pi into 200. It is 9549.3, and unit is Newton meter. Remember, always remember, this is important. When we put watt in power formula, then torque comes in Newton meter. And 1 kilonewton is equal to 1 into 10 raised to 3 Newton. So 1 Newton is equal to 1 into 10 raised to minus 3 kilonewton. So this is 9.5493 kilonewton meter. Next step, principal stress. So see, this ZP and T we had calculated. Now put this ZP and T and M is in this formula. 1 by ZP, 1 by 196.34 into 10 raised to 3. Now this principal stress is sigma is equal to, see this equation, 1 by ZP into M plus minus under root of M plus T square. This principal stress we need in MPa. Unit is MPa. That means MPa is also Newton per mm square. So this ZP is in mm cube, and this C, this torque is in kilonewton meter, and this moment is also in kilonewton meter. So we need to put this moment is in Newton mm, 5 into 10 raised to 6 Newton mm, and this is 9.5493 into 10 raised to 6 Newton mm. So that's why units are similar, Newton mm, and mm cube. So 1 by ZP is this 196.34 into 10 raised to 3. Multiply by M is 5 into 10 raised to 6. Plus minus under root of 5 into 10 raised to 6 square plus T is 9.5493 into 10 raised to 6. Square. So this sigma is, see this 10 raised to 6, this 10 raised to 6 square, this 10 raised to 6 square, take common. That means under root of 10 raised to 6 square, under root and square get cancelled. This 10 raised to 6, 10 raised to 6, take common here. 10 raised to 6 divided by 196.34 into 10 raised to 3 multiply by 5 plus minus under root of 5 square plus 9.5493 square. So this principal stress is 10 raised to 6 upon 196.34 into 10 raised to 3. It is 5.093 multiply by 5 plus minus, this is 5 square plus 9.5493 square. That means 10.77, 10.78. So now maximum principal stress is 5.093 into 5 plus 10.78. 93 multiplied by 5 plus 10.78. It is 80.37 MPa. For this maximum principal stress, we use this plus symbol. And for negative principal stress calculation, use minus symbol. So for minimum principal stress calculation, use minus symbol. So 5.093 multiplied by 5 minus 10.78. So minus 29.44 MPa. Now next is maximum shear stress. So maximum shear stress is maximum principal stress minus minimum principal stress divided by 2. So 80.37 minus 29.44 divided by 2. So it is 54.91 MPa. Now next step is principal plane calculation. So principal plane calculation formula is tan 2 theta is equal to T by m. So therefore this 2 theta is equal to tan inverse of T by m. So we know that T is 9.5493 divided by m is 5 and tan inverse is 62.36. And divided by 2, that means this theta comes 31.18. degree. So these are just mathematical calculations. Theta 2 is equal to theta 1 plus 90 degree. Theta plus 90 degree. This is theta 1. Theta 1 plus 90 degree. So 31.18 plus 90 is 121.18 degree. So this is shaft of 100 mm diameter, transmit 200 kilowatt power at 200 revolution per minute, and at a section bending moment is 5 kN/meter. Principal stress is maximum principal stress is 80.37 Newton per mm square, or MPa, and minimum principal stress is minus 29.44 MPa, and maximum shear stress is 54.91 MPa, and principal plane is 121.18 degree, theta 2 and theta 1 is 31.18 degree, and polar sectional modulus is 196.34 into 10 raised to 3 mm cube, and torque twist is 9.5493 kilonewton meter. Thank you very much.